Hey everyone, Teacher Chang here, and today we're going to go ahead and take a look at the intersecting chord theorem. So let's go ahead and see what that is. So the intersecting chord theorem states that if two chords intersect inside a circle, then the product of the segments from one chord is equal to the product of the segments from the other chord. So what does that mean? Well, the first thing that we need here is that the two chords, there has to be two chords that's going to intersect inside our circle. So we have two chords. We have one that is in blue, which contains the A and the B, and we have one that is in red, which contains the C and the D. So the theorem is actually stating that the product means to multiply the segments from one chord. Well, segments means a piece of that chord. So here we got two pieces of this first chord. So I'm going to take a look at the blue chord, and that blue chord is being cut right over here by that other chord, and that's going to break it up into two segments. And the segments that we have here is A and B. So if we were looking for the product, well, that product means A times B. Well, the same thing happens with the second piece. So it has to equal to the product, again, multiplication, of the segments from the other chord. So the segments from the other chord are the two pieces, which is C and D. So the product means to multiply those two, which is C times D. So those two should be equal to one another, according to this theorem. So now that we know this theorem, we're going to go ahead and put this into action to help us solve for missing pieces. So let's take a look at our first example here. So here we can obviously see that we have two chords, and the two chords are intersecting one another. So we have this first chord right over here, and that's being intersected with the second chord right over here. Okay, now where they intersect, that's going to give us that intersecting point over here, creating segments. Remember, segments means pieces of something. So if I take a look at my first chord, the two pieces that I have is going to be the x and the 15. And the product of it means to multiply them. So I'm going to do 15 times x, or x times 15, which is just 15x. Now, what we're going to do is we're going to take the product. That should equal to the product of the segments from the second chord. And well, the segments from the second chord is the 9 and the 5. So if I multiply those together, that's going to give me 45. Well, now all we got to do is solve for x. And to solve for x, I need to get x by itself. And to do that, we're going to divide 15 on both sides. When we divide 15 on both sides, well, x is equal to 3. So that one's a nice, simple one. So we'll go ahead and take a look at another one, a little bit more difficult. So let's take a look at this next one over here. So in here, again, we have two chords that are intersecting one another. So we got one going down this way, and then we have another one going in the opposite direction, or the other direction, left and right. And they're intersecting at this point right over here in the middle, giving us segments. So what we're going to do is we're going to take a look at the segments in the first one, and the segments in green is the 12 and the 3x plus 1. So if we were to find a product, well, that means I have to multiply 12 times 3x plus 1. And that's going to be equal to the product of the segments from the second chord. So I need to multiply the 8 and the 24. So 8 times 24. Okay, so now all we got to do is a little bit of math here. So I'm going to start off by distributing that 12. So 12 times 3x and 12 times 1. So 12 times 3x, 36x. 12 times 1, that's 12. And that's going to equal to 8 times 24. And 8 times 24 is 192. Okay, so now we got a two-step equation. 36x plus 12 is equal to 192. And we know how to do our two-step equations. We want to get x by itself. So we're going to get rid of that 12 by subtracting 12 on each side. The 12s on the left will cancel each other out. That's going to leave us with 36x is now equal to 192 minus 12 is 180. And now we got to get rid of that 36. So we'll just divide 36 on both sides. The 36's on the left will cancel each other out, leaving us with x is now equal to 5. So x is equal to 5 here. All right, not too bad. So let's go ahead and take a look at one more problem here. And this one, again, a little bit different than the previous one. So here, again, I have two chords intersecting one another. So I usually like to look at the ones with the X's first. So there's our first chord and our second chord right over here, giving us different segments or segments within each chords. So I'm going to take a look at the first one, and again, the product of the segments from the first chord is going to be x minus 9 times x minus 13. Okay, and that should be equal to the product from the segments in the second chord, which is 32 times 21. So I'm going to write that out, 32 times 21. All right. A little bit more difficult, but something we can do. We've done stuff like this in the past. So the first thing that we need to do is we need to go ahead and simplify this left side. And to do that, we're going to FOIL or use the distributive property. So I'm going to distribute that x. So x times x is x squared. And then x times negative 13, well, that's negative 13x. When I'm done distributing that x, I'll distribute the negative 9. Negative 9 times x is negative 9x. And negative 9 times negative 13. Well, negative times a negative is a positive, and 9 times 13 is 117. Now, all of this is equal to 32 times 21. 32 times 21, that's 672. Okay, so now that I have this, we're just going to simplify this left side here by combining our middle terms here. And when I combine that, I'm left with x squared, negative 13x, and negative 9x. That totals out to negative 22x. We'll bring down to 117, and all of this is still equal to 672. So obviously, we have a quadratic equation here. So we could solve this in many different ways. You could use a quadratic formula. You could go ahead and do it by factoring. You could go ahead and do by completing the square. I'm going to go ahead and do it by factoring. So to factor, that means I have to set my equation equal to 0. To set it equal to 0, I got to get rid of this 672. So I'm going to subtract 672 on both sides. So that way the 672s on the right will cancel each other out, giving us that 0. And now I'm just going to simplify everything else out here on the left. So now I got x squared minus 22x, and 117 minus 672, well, that's going to give us negative 555. All right. So when I'm factoring, I know that I'm going to get the format. I have two factors here. Something times something is going to get me that trinomial, which is all equal to 0. And I do know that in the beginning, since the leading coefficient here is 1, I'm going to have an x here and an x here, because x times x is going to get me that x squared. Now, to get the rest, well, I need to figure out what are factors of negative 555. Yet, at the same time, those factors are going to add up. The sum is going to be negative 22. Okay, so what times what is negative 555, yet at the same time, it's going to add up to negative 22. Now, if you don't know, you could use your calculator. If you have a graphing calculator like I have here, this is what you can do. You can click on y equals, and then you could go ahead and type negative 555, because that's what I want factors of. And if you divide it by x, that means whatever x is, 1 times negative 555 will get me that negative 555. So I'm going to divide it by x, and then I'm going to click on table. And when I click on table, I have all these factors that give us negative 555. So all of these will get us negative 555. Now I'm going to go ahead and look for one. So let me go back down to 0 here. Let's take a look at what we have here. So for example, we have negative 1 and 555. So that's obviously negative 555. So I want to find out one pair that's going to add up to negative 22. So negative 3 and 185, that gives me negative 555 when I multiply, but that's obviously not going to add up to negative 22. So I'm going to scroll around and I'm going to look for a pair that adds up to negative 22. So here we got negative 37 and 15. Well, negative 37 times 15 will get me that negative 555. And if we add them, well, that's negative 22. So I'm going to use negative 37 and 15. So I'm going to write that down over here. So negative 37 and positive 15. Those are my two factors. So now that I have my factors, I could go ahead and set each of these equal to 0 and solve for x. Using the zero product property, I could set each of these equal to 0. So x minus 37 is equal to 0, and x plus 15 is equal to 0. So I set each one equal to 0. Now all I got to do is solve. So in this first one on the left, add 37 on each side, and x is equal to 37. Okay, on the right, we could subtract 15 on each side, and x is equal to negative 15. Now, the thing is, we can only have one answer in this particular case. Now, that answer is going to be x is equal to 37. It's not the negative 15. Why not? Because we can't have a negative length. So you can't have a negative length. So that's why we can't have a negative 15 as our answer. Okay, well, that's how you use the intersecting chord theorem. I hope this helped out. If you have any questions, go ahead and leave a comment. And don't forget to like the video and subscribe. All right, good luck, enjoy, and have fun.